This is week 11, and I'm going to go through some guided notes for solving equations. So you pull the notes up, and you can print them or write all this down on your own paper. As we've been talking and watching the videos, you have discovered that solving equations is like unraveling a mystery. Okay, so the first thing you need to look at is your vocabulary. An equation is a mathematical sentence with an equal sign. So I'm just going to highlight a few words here. Equation has an equal sign. The following are all considered equations. Example, 9 plus 2 equals 11, x plus 7 equals 37, a plus negative 3 equals 2a plus 5. All three of these are examples of equations because they're a mathematical sentence with an equal sign. A solution of an equation is a value for a variable that makes the equation true. Okay? You substitute a number for a variable to determine whether the number is a solution of the equation. Okay, so let's go through a couple examples. Is the given number a solution for the equation? Please show how you arrived at your answer. So these are already completed, some of them for you. So the first one, example, is 170 plus x equals 200, for x equals 30. So we take 30 and sub it in for our variable x right here. And 170 plus 30 equals 200. So we say that that is a true statement. Yes, 30 works when you plug it in for x into that equation. Going across the next example, 3 equals 12 minus a, for a equals 6. Okay, so we take the value of 6, plug it into the equation, and see if it works. 3 equals 12 minus 6. Well, 12 minus 6, or 12 take away 6, is not 3, it's 6. So we say that one is not true. That does not work. Let's try this next one together. 9 take away m equals 3, for m equals 6. These are equal signs. Okay? When I plug in 6 for m, then I do the computation on the left, and the answer is yes, because we have a true statement. 3 does equal 3. So it checks out. The next example, 8 plus t equals 2t, for t equals 3. So we're going to plug in the value 3 for t. And on this side, we're going to do 2 times 3 because 2t is 2 times t. Okay? So 8 plus 3 is 11 equals 2 times 3 is 6. That is not true. 11 does not equal 6. So the answer is no. 3 does not work into that equation to make the left side equal the right side. Next page. Solving one-step equations. Important rules for solving equations. When you solve an equation, your goal is to get the variable alone by itself on one side of the equation. In other words, you're trying to isolate the variable. So get the variable alone by itself on one side of the equation. You're trying to isolate the variable. Rule number 2, when you are solving for a variable, you must use inverse operations to isolate the variable on one side of the equation. And I'll explain that. Rule number 3, whatever you do to one side, it's like a balance of an equation, you must do to the other side of the equation. In other words, you must keep the equation balanced or equal. Think of solving an equation like lifting weights. If you add or subtract weight from one side of the barbell, you must add or subtract the same amount of weight from the other side to keep it balanced. Draw a line between inverse operations. So the inverse of addition is subtraction. The inverse of multiplication is division. Or sometimes we say opposite. But we're going to use inverse operations. So you have to know the inverses. Solving one-step equations by adding or subtracting. When you are solving an equation, you must use the inverse operation to isolate the variable on one side of the equation. Remember, if you add or subtract a number from one side of the equation, you must add or subtract the same number from the other side of the equation. Examples. Solve each equation for the variable. X plus 4 equals 6. So these are some of the things you need to be asking yourself. How can I isolate this variable or get it alone by itself? Which operation do I need to use to solve the equation? You can always check to see if your answer is correct by substituting it back into the original equation. So here's your variable, x. How do I get it by itself? Well, 4 is being added to x, so I'm going to subtract 4 from both sides of that equation to get rid of it on the left side. The opposite of add 4 is subtract 4. And what we do on one side, we have to do on the other side, both sides. Okay, so it'll balance. That leaves x equals 2. We check it, plug it back in. 2 plus 4 equals 6. Yes, that's a true statement. So 2 is the correct answer. The next example. How do I isolate this variable or get it by itself? And what operation do I need to use to solve the equation? Y minus 5 equals 12. So I'm going to isolate y by adding 5 to both sides. When I do this, on the left-hand side, the 5's cancel, and I'm left with y equals 17. So let's plug it back in and see if it works. And the answer is yes. So it does work. It is the correct answer. Okay, inverse operation here was plus 5. Directions. Solve each equation. Okay, so you're going to have to solve each equation. I'll get you started. Isolate the variable by doing the inverse operation to both sides. So I'm just going to highlight the variable and get you started with the inverse operation for each equation. What you're going to do to both sides of the equation to get the variable by itself. Here's your variable. You should be able to do the next 3. By yourself. Okay, those are your answers to the top 3. I showed my step, my inverse operation, circled my correct answer. You need to try the next 3. Okay. Now we're going to try some different variations of solving some equations. You can express one-step equations in different ways. It doesn't change how you go about solving the equation. Okay. All right. So let's practice these. These are a little different. The variable is on the right-hand side in all 3 of your top examples. Okay? So let me point that out. The variable's on the right-hand side. I always want my variable on the left-hand side. So what I'm going to do real quick is I'm going to switch sides for these 2 expressions. I'm going to keep my equal sign, and I'm going to put my t plus 2 over here and my 11 on the other side. So I'm just switching the sides that each expression is on of the equal sign. I'm going to do that in the last ones as well. There's my variable. It's on the right. I want it on the left. So I'm going to switch it. R take away 5 equals 21. And y take away 16 equals 100. I did not change any values of anything. I just switched the 2 sides. From there, you can perform one operation to isolate the variable by itself. And it should be pretty easy to get started here. So I will show you this one. And I'll pick one more. I'm going to pick this one right here. I'm going to add 5 to both sides, and r would equal 26. Now you should be able to do the rest, okay? On your own. These are simple one-step equations, adding and subtracting. All right, whenever you see a variable, it's understood to have a 1 in front of it. Some examples. So variables always have a coefficient, which is the number to the left being multiplied to the variable. But if you see nothing, like a plain old x by itself, it's really 1x, okay? Y take away 4 is really 1y take away 4. And in the last example, well, one of the last examples, x equals negative 14, it's actually 1x equals negative 14. Now, I can pair this. That's an invisible 1. You don't have to put it there. But I say, like, when we're talking about, hey, look at that car, we don't say, hey, look at that one car. We just say, hey, look at that car. It implies that it's one car. So in this one, we've got 1t divided by 4 equals 4. All right? Okay, so let's move on. We've solved some equations using addition and subtraction. Now we're going to use multiplying and dividing. So your goal is to always use the inverse operation to isolate the variable. Remember, if you add or subtract, you must add or subtract on the other side. The same number from both sides of the equation to keep it balanced. So let's try a few of these. We should say when you multiply or divide. We got to change this up. You must multiply to the other side or divide to the other side. Missed that. There we go. Okay, let's go through some examples here. How many do I have? 3. All right, so this example, first example here, 2p equals 18. Well, what's going on between the 2 and the p? Well, I could say that they're being multiplied because that's what's implied when you have a number bumped up against the variable like that. It means there's multiplication happening between that whole number or that rational number and that variable. So the inverse of multiplication is division. Now, when you're younger, you're probably taught to show the division like this. Well, we have graduated to just using a fraction bar because a fraction bar is division. The next example, 4x implies that we have 4 times x equals 8. So to undo that, we're going to divide by 4. Divide by the coefficient. X equals 2. Okay? The next one, we have z divided by 14. Now, I want to get rid of that 14 in the denominator, so I'm going to clear it out by multiplying, because the opposite of division is multiplication. So z equals 28. All right, there's some examples to work for you. Okay, so let's move on. We are going to solve some more equations here, some more examples for you. All right, and here we go. Solve each equation. Again, in these, some of these, no, all of these, the variables on the right-hand side, I'm going to rewrite them so that the variables on the left-hand side. 4b equals 16, 5c equals 20, d divided by 8 equals 5. I'm just switching the two sides here. And s divided by 2 equals 11. Okay, the old switch. All right, now I look at the first one. I say, well, 4 is being multiplied to b, so I'm going to divide by 4. I'm going to set these up for you. The next example, 5 is being multiplied to c, so I'm going to divide by 5. Sorry about that. The next one, d is being divided by 8. So to undo division, I have to multiply by 8. And d will equal 40. The last one, s is being divided by 2. So I have to undo that with multiplication by 2. And the top ones are b equals 4. I have a calculator, or I already know my multiplication facts. C equals 4 as well. Okay, those 4 worked out for you. Whenever you see a negative sign in front of a number or variable, it is understood to have a negative 1 in front of it. We talked about the invisible one. Now we're going to talk about the invisible negative one. In solving equations, you do not want to leave a negative, like a negative x equals 10. You don't want to leave it like that. You want to fix it. So the first one says negative 1x. The next one says negative 1y plus 1 equals 5. I'm just putting in my invisible 1 so that you guys start to recognize that a negative sign in front of that variable means there's an invisible negative 1 in front of it. Okay. All right, so we just had to rewrite these and put the negative 1 in front of the variable. Let me highlight that. Negative 1, negative 1. There you go. Now we're going to solve some with negative integers, okay? So let's work through a couple more examples. D plus 3 equals negative 6. Well, there's my variable. Want to get rid of this plus 3 by subtracting 3. D equals negative 9. So I did negative 6 minus 3. The next one, x plus negative 8 equals 12. Now some kids will say, it's a negative 8, so I'm going to add 8, which will work. Okay, and then you get x equals 20. I like to rewrite this expression as x minus 8 equals 12, and then add 8. Either way is fine. Okay, the next one, negative t plus 5 equals 9. I'm going to put my negative 1 in front of my t so that I can solve this correctly. Then I'm going to subtract 5. And now I have this. But I have a negative 1 being multiplied to t, so I have to undo that with dividing by negative 1. Because I don't want a negative 1t, I want a positive 1t. So I have to divide by negative 1, which gives me t equals negative 4. You can't leave it with the negative 1 in front of the variable. Okay, the next one, I'm going to put in my negative 1 in front of my p, and then I'm going to subtract 6, because those will cancel out. Now I have negative 1p equals negative 13. Can't have a negative 1p, so I have to divide by negative 1, because it's being multiplied. So p equals positive 13, because a negative divided by negative is a positive. All right. Okay, now you've got some that you can do on your own below. Okay, if you have any questions, let me know. Almost done with the notes here. Oh, we've got a lot of good practice here. Okay, what I'll do is I'll let you practice, and then I will post the key later in the week.